Hello friends, let's continue our series. For the lecture number 19, we will be learning about naive Bayes classifier. So what is a naive Bayes? It is a probabilistic classifier based on the Bayes theorem. It is called naive because it assumes that all features are independent, right? Which is rarely true in real life, but still works surprisingly well. So what is a naive Bayes, guys? The naive Bayes is a probabilistic classifier which is based on the Bayes theorem. I hope you are all familiar with the Bayes theorem. If not, you can look it up. It is called naive because it assumes that all the features are independent, and this is not true in real life, guys. In the classifier, it's it's hardly possible that all of the features are independent. The features have to be depending on each other. If not all, then at least some. However, it works surprisingly well, you know, even after assuming that all features are independent, it still works surprisingly well. So let's check how it works. It calculates the probability of each class given in the input features, right? You are given the probabilities of each of the classes. It basically just calculates those using prior probability, like how common each class is, and likelihood, how likely the feature are in each class. It chooses the class with the highest probability, right? So what does this mean? It uses prior probability, meaning the probability of the past or the probability in the past, and checks how common each class is, right? It can check which class is occurring a lot, it can check which class is pretty rare to occur, it can check which class like to occur occasionally, and so on. And the likelihood, meaning the odds or the chances, how likely the features are in each class, right? Based upon this, it chooses the class with the highest probability, the class whose possibility of occurrence and existence is highest. So why do we use it? We use it because it is extremely fast and efficient even with large data sets. It performs well with text data and natural language processing. It works great when features are somewhat independent, like in spam detection. And where it is used? It is used in spam email detection, sentiment analysis, document classification, etc. What are the limitations regarding this? It assumes feature independence. It doesn't capture feature interactions, right? So it assumes that the features are all independent and not dependent on each other, rather than capturing the feature interaction, you know, how they interact with each other and how they are being interacted, stuff like that. It is not very flexible. Performance drop if the data set doesn't fit is assumption, right? We have to make sure that the data set follows its assumptions, because if not, it will not be flexible because of the performance dropping. And finally, it can struggle with rare categories or small data sets, right? As you can already understand, for the categories that are rare to occur and the data sets which are small, there can be a lot of the errors, especially when you are training your model in such a way. And well, that was it. I hope you were able to understand. Thank you for watching the video.